let's continue on with our next shot. So we can recycle most of this. Obviously, we'll get rid of the tornado, the grid, probably make another one later. Camera and the light. And let's drop a geo to bring in our fracture geometry. So call this fracture. Excuse me, jump inside, drop a file, and save this as well. So I've already got one fracture. Okay, so give it a new hip file, but keep it in the same hip location. Okay, so file, and then grab the, go into your geo, and then I've got here the fracture. Okay, grab that. Then you can see it's starting a bit late, just like the tornado. So we just need to bring it back into the correct time. So drop a time shift. And again, if you want to make this yourself and you haven't done already, then go ahead and check out the first Renaissance course, because that's where it is produced. Okay, so that will push it back to the first frame. Oops, made a mistake there. $F plus 145, there we go. Okay, so we got it from the first frame there. As you can see, it's a bit slow, so what we're going to do is kind of sort it out and kind of pack it up and use points to drive the pieces. Before we do that, let's place it in the city. So I've got these values kind of worked out, but we can turn on the city just to see where it goes. We turn off this crowd, maybe set it back here so we're not simulating by accident. So back into the fracture, and I'm going to scale it up 1.3 and then just move it in X and Z. So minus 21.8094, and in Z minus 17.3633, and then we'll drop it about there. Okay, and then we'll just have a camera kind of from the top like that. Obviously agents running along and falling into the hole and so forth. So these are still packed fragments, so let's convert it back into normal polygonal geometry. Hide this again. The normals are back to front. Reverse them. Give it some color. Maybe it needs normals on that first. There we go. Looking better. If we press spacebar and F, we can see we've got this is the ground plane from the previous simulation. So we'll just delete that. Go. Easy peasy. Also, we've got all these attributes from the previous simulation, which could mess up, well, most likely will mess up our simulation. So we'll just delete everything from the points and the primitives, and here with their normals and UVs, we can leave them. So attribute delete. Always a good idea to delete any attributes which you don't need, because they can cause problems down the line, and also just to save disk space basically. Great, so now we got this kind of clean, simple geometry. We can start preparing it for our purposes. So giving it a name first of all. So we'll just call this ground. So I'm not going to pack it yet because I want to grab these transformations, right? Extract transform. So this will take, this will kind of measure the movement of each piece, and based on each, if I comparing it, with the first frame here. Use a time shift to grab first frame, which will always stay the same. Plug that into the second port, and based on the name, so each piece will have 1 point, and the transformations and rotations and everything, will work out a whole transformation matrix for us, will be calculated from this geometry. We don't have any deformation in those pieces. There is, that's probably why we got an error here, because there is one piece, if you look here at the bottom, this thing, we've got changing point numbers on this, but that doesn't matter. We've got the rest of it will work fine, and this, we just kind of ignore that. Right, so and then what we do is use these points to transform these pieces again, which should be quicker and quicker for us. Okay, obviously you could just use these points straight off from the start, but I thought it was good to show this process for when you receive animation from, could be not from Houdini, that's unpacked, and this, once we get these points, we can kind of simplify the geometry so that it goes a bit quicker. Cool. So we'll cache out these points, right? So I'm just going to do 100 frames. Oops. Let's do delete channels. We have 150 or so. 1, 4, 5, 3. So we got 155. So you can cache out that many points. It's up to you. I've already got them cached out, so I'll just grab the ones I've got saved. Fracture points there. Okay, so just make sure you set up your route correctly with with your frame number and geo there. Load from disk, so that will play super quickly now. Great, and so I want to use these as a collider for my simulation, right? So if I go through each frame, I obviously get one jump per frame. Now when I go into my simulation, I'm going to have sub-steps. So between each frame, there's going to be calculations happening on the position of my agents on between each frame, and with these jumping per frame and not with sub-steps, we'll get weird kind of explosions. Maybe I'll show you later with this turned off. But to to solve that problem, what we need to do is use a time blend, okay, which will interpolate. Just check this second checkbox here: interpolate rotation of normals, quaternions. And this, we can't see it here, but one way to check is if you go into your animation settings, options, global animation options, and turn off integer frame values, and you can see we get float values, and between each frame we get movement. Okay, and there's nice interpolation between the frames there. Okay, and then what I'm going to do is drop a time shift, because I want to slow this down by half. So multiply that by 0.5, and I'll get a nice slow motion thing going on. Not slow motion, but just to give it a sense of weight, right? Cool. So what we need to do now is take these points and apply them to the pieces here. Okay, these are frozen now, so we can't just grab a transform pieces. Okay, so we take the points into the right, pieces into the left, and this is based on the name. You can use any attributes, but the name is the convention, and you can see them moving there. Obviously, we need to set this back to integer frames. Okay, but we need to, well, what I want to do is drop a convex decomposition. What this will do, this is a new SOP that came out in Houdini 17, I think, which basically prepares your geometry for bullet simulations, which is quite nice. This geometry is pretty good anyway. It's not so convex, but it will just simplify it because we got a lot of points, right? You can see that what it'll do is break down your geometry into convex pieces, okay? And then I'm going to pack this up, and based on the name, we need to transfer the name across and make sure the name attribute is on the points. So here it's on primitives, and let's make sure it's on the points. And then now this should move pretty quickly. Yeah. Okay, so we got a nice kind of fluid movement moving across. Great. Okay, so that's ready to go into our simulation. Maybe I'll drop a null here. Out, I'll call this call for colliders. Okay,